Hello, I am Adam, and since about 1 week I'm an electrician. Okay, generally I'm in a stage where I'm changing my one-phase electrical connection to my house, and I'm upgrading it to 3 phases. And of course my electrical switchboard needs to be upgraded. And generally, I of course had to specialize in this topic, and I had to find optimal way. And generally, I want to make a video just to inform you that what could you be aware of when some electricians could do. And yeah, of course, you have to remember that you need a certificate in a lot of countries to truly do that. But in this case, I will be talking about devices that I used and why I used them. Yeah, so the main goal is to upgrade electricity in my house to 3 phases and include an electric car charging point. Yeah, I live in a flat, so that's tricky one. Yes, okay, so first let's start with the whole electrical switchboard, and let me take this out, and that's what is left from the electrical board because it's mounted. Anyway, I went with the Hager Golf, that's the model of the box, the enclosure, and in 2 words, what you need to be aware of when choosing a electrical box, because well, you may have a decision in this, yeah? First thing is that if you mount it in a box, there need to be a clearance to the wires, yeah? So as we can see, I can easily put there anything underneath the whole rail. So that's great, yeah? Another thing, as you can see, I have a removable tray, so I can place everything in a very comfortable position on my desk. And after I mount everything that was needed, I just take it and put it and lock it on 4 screws, which are located there. And it's mounted, yeah? That's a pretty nice thing. And another thing what you should check is size, because of course, talking about modules, 12 in each row, well, you need to calculate how much you will need and have about 20% of space for anything else. But I'm talking about physical dimensions of the box, because previously I had just only one lane, and I had to make the hole in a wall bigger to hold whole box, which was about 50 centimeters. Yeah, so I went up for like 30 centimeters. It took a lot of time, to be honest, so be aware of that. Okay, and now let's talk about what devices I will use and why I use them. The first thing is that we need a switch at the very beginning. So yeah, it's just a switch, it turns off and on, 3 phases, and that's it. In some cases you might find that there is a 4th slot for the 4th cable, it's for the neutral, and the switch might look different. Be aware, don't use 4 phases for 3 phases and neutral, because you have to use a special switch which first connects the neutral, then connects the phases. Otherwise, it can make a very big mess. I'm using 3 phases, and my neutral is connected directly to my terminal strip, which is divided, let's say, before RCDs. Yeah. So we've got the switch. Next thing is I will name it a surge protection, some thunder protection, whatever. And this thing is going next to it, and yeah, I'm connecting the phases goes from up, and from down I'm connecting the all 3 phases, and neutral goes to the strip that I mentioned, and of course the PE goes to the PE. There is no deviations. And next, my idea was to use in this row RCD for 3 phases. That's how it looks. That's how it looks. What are the inputs? 3 phases, neutral, output, and neutral. Of course, you can go in an opposite way, that doesn't matter. And yeah, that's my first row, because this is 11, and in this slot I will mount a monitoring device to monitor my current consumption. And I probably make video about later when it comes to me. And next we could have a single phase RCDs. So those are like this, and as you can see, those has the QuickConnect rails. So there's a thing, and it's beefy 60 square millimeter, and you can slide it up. Okay, because what's the problem with that? If you put it there, as we can see, there is a live, there is a neutral, so we need to remove the second teeth. And fortunately this is slidable, so I can just slide it up and cut somehow this one teeth, and it will be still perfectly fine. And after we mount it, and there goes circuit breakers, the overcurrent protections for the circuits that we've got. For example, B10, that's 10 amps, which is good for lights. And maybe towards about the QuickConnect from the Hager. Generally it's working like you press there a spring, and you can put there a wire up to 4 square millimeters. And generally I think those are better, because the standard strips are going to lose in time, and that's why every few years you have to make a electrical switchboard review, because the electrician just will take a look for each screw if it's loose, and just he will screw it up. So generally that's how it will go. And of course I will have 3 phases, so I will use 3 RCDs. So one would be there, and second would be there, and third would be there. I need a overcurrent protection for the 3 phases for charging a car. So there is my 3 phases circuit breaker. And, I did wrong. That's how it should look like. Because this is only a connector. It turns on and off. And this is a circuit breaker, B16. And I will connect it like it goes from this, 2 cables go there. So I will take the live wires to the top, and from this I will go to the bottom, and I will have 3-phase output like there, and neutral there, and PE will be from the terminal strip. What else I could say? As you can see, this is my there is approach that I've got for every circuit, single RCD. For example, for charging car, I've got their RCD, which supports 3 phases, and there is a circuit breaker for this. And for my first phase I've got this single phase RCD, and for second and third phase I will have more RCDs, but I don't want to unbox them. And that's generally how my electrical switchboard will look like. And now I would like to talk about terminals. Standard terminal is you got strip with screws and those can loose, and to be honest I hate that, because I saw in my case like 5 years old installation, screws are getting loose and that's terrible. So I recommend using this type of quick connectors. And it works same as those in the circuit breakers. So generally if we've got a wire, we just insert it there and it's connected. A spring is applying same force over time and nothing can lose in time. That's great. And if we want this, those are to maximum 4 square millimeters. If you want to put a bigger wire, in my case I will be putting 10 square millimeters, but this is up to 16 square millimeters. So in this case we've got very nice clamp, and well, it will be much better than just stupid screw. And yeah, this clamp is similar to those circuit breakers terminals, so I assume it's much better holding. And yeah, okay, we see screws, and there is one important thing, but let me find this. Okay, I found that. There is one important thing, because old electricians can just screw those screws as hard as they can. That's bad. Of course, it will work if we put it there and screw, and it will work, but the way how it should work is that if we put it there and screw it with vendor-specific strength, for example, in this case we've got 2.8 Newton meter, whatever, and I've bought this thing for pretty cheap, because those things are very expensive, because those needs to be very precise. How to get there? Okay, and that's how it looks like. Well, what could be inside? This is a tip for the Wiha screwdriver, and I think inside there is a spring which skips the teeth or whatever, makes a click when 2.8 Newton meter force has been applied. So, oh my gosh, I cannot do it in a... By the way, it's metal inside, so it's great quality, I must say. Yeah. Okay, what else I can talk about? Of course, those strips has to be cut to have a specific length, and after you cut, you can buy those caps. Oh, let's see if those will fit. More or less, yeah, it fits, but it doesn't look nice. And yeah, so two words about three-phase output for the car, because currently we've got this circuit. So we've got RCD, which cables goes to this circuit breaker, and there is an output for the car. What next? Next goes a three-phase cable. Maybe this is a nicer. Yeah, this is very big cable. I've got there 5 times 4 square millimeter. Of course, it depends which size you want to use on the range that you are using. In my case, I needed only about 1 meter, but generally I did a three-phase socket just under my electrical switchboard, and I just had way. I just wanted to have that thick cables. Of course, 2.5 square millimeter will work perfectly fine. Generally, the size of your cable matters when it's going to range, and I will talk about this later, because first is the connector, and that's how the connector looks like. This type of connector is flush mounted, so I had to make a hole in a wall, but anyway it will look pretty slim and fine. I found this for very expensive, but yeah, it looks very nice comparing to the red industrial ones. And yeah, that's how it looks. And yeah, it's got just screwed. Be aware which size of cables you can put there. In this case, it's 4 square millimeter, so everything fits. And my plan is to have it under my electrical board, and I will have like maybe 15 meters of extension cord, and this extension cord will be 2 in 4 square millimeters, because on that distance the voltage drop, by the way ChatGPT can very nicely calculate that, the voltage drop on those cables, because 2.5 square millimeter will be fine too, because it's only 16 amps maximally to get 11 kilowatts power, yeah. But I decided I will go with 4 square millimeters to just minimize the voltage drop, so to minimize the heat which will be on this cable, etc., etc., and the price is not that much difference. So yeah, I will go with extension cord with 4 square millimeters. There will be about 1 or something voltage drop difference comparing to the 2.5 square millimeters. And that's the way that I want to go to church soon. Not now, because I don't have electric car, but yeah, I will have soon an electric vehicle, so that's my way to charge it, because I'm living in a flat but on the ground level, so I open the window and I can touch the car, so I see there is a way to charge a car also. And yeah, 11 kilowatts is I think pretty decent amount of power that in a normal flat scenario is achievable, because of course my electricity provider needs to increase this power, and I asked for 16 kilowatts. Currently I've got 4, which is well, you need to think if you connect something. With 16 it will be fine. When I will charge the car, I will have something what I've got now. And crimping tools, oh, this was topic pretty nice to discover, because let me take this, and you can find this crimper. It changes the name, the mechanical design is same. So as we can see, it's from 0.1 to 16 square millimeters, and yeah, it's accepting the 2 cables 10 square millimeters each. That means there I've got about 20 square millimeters, but fortunately this fits there, barely, but fits, and I was able to crimp this end. And as we can see, the pattern is I didn't saw that before, but yeah, maybe I don't see if you see that. Yeah, you should see that. Yeah, so the pattern is not the hex, but yeah, it's still fine. And of course it should fit there, but oh, be aware, double tips won't fit there nicely because of the double cables. As you can see, as we don't see the end of the tip there, and it looks like ugly. But the single ones work perfectly. Yeah, if you put it there, it goes yeah, straight to the end. We can see the copper is there. Yeah, And yeah, so I'm crimping those tips using maximally 16 square millimeter size, and yeah, it's working. It was expensive, to be honest, but yeah, it's working fine. Previously I had a crimper which could do maximally 6 square millimeters, and yeah, that's not the size. And yeah, thanks for watching. Please leave a comment and hit the subscribe button. Bye.